Hey guys, and welcome back to another video on the channel. In today's video we're going to be solving a student submitted question. This is one I've done with all my students in tutoring, so we're pretty much just going to do it. So this is a projectile motion question. So a particle is projected from the origin with an initial speed of v and at an angle of theta to the horizontal. You may assume the equation of it is a parabolic path. So as example given question 7, we don't have question 7, so just assume that it's going to pretty much have a path like this. And we're assuming it's flat ground because it's gone from the origin. So that means x equals 0, so the horizontal position is 0, or displacement, and y is equal to 0, so the vertical displacement is also 0. You may assume, yep. Find dy dx, and hence show the vertex of the parabola is v squared sine of 2 theta over 2g, and v squared sine squared theta on 2g. So that's your x and your y coordinate respectively. Okay, so with this, we need to use pretty much vector calculus. So we have a scenario like this, where we have a particle that's been shot with a velocity of v at an angle of theta. Now we don't know what those are, but we do know your initial velocity here, because you have the components. So you have this vertical component and this horizontal component respectively. So this component here would be v sine theta. So that's your vertical initial component of your velocity equation, and this would be v cos theta. Okay. So from that I know that r dot t, so your velocity vector equation of 0, so t equals 0, is the following: v cos theta I hat, or I, plus v sine theta j hat. Okay, so the unit vector is in those directions. Okay, so I know that straight away from that initial bit. Okay, now I also know we're on Earth, so your acceleration equation is only in the vertical direction. So acceleration due to time is strictly going to be what is it? G J. So just acceleration due to gravity. And then pretty much we've got to define what g is. So we'll say g is 9.8, and since it's going down, we'll just say it's minus g. So let's just put that as a minus g very quickly. So minus g. Okay. Now to work out your velocity equation, you need to integrate each of the components. So there is no x component there. So if you integrate that, you're just going to have a constant there. So constant I hat. Okay. Plus integrating this with respect to time, you're going to have minus gt plus a constant. Now, these constants here are your initial velocity, because if you set t equal to 0, all you're going to have is that constant, and that term is going to be 0, so you'll just have that constant. So these c's, respectively, are these bits here. So you can plug those in straight away. So if I move that away, we get r dot of t is equal to v cos theta I hat plus minus gt plus v sine theta j hat. Okay, so now you've got an equation for velocity at the moment. So that's around the j and that's around the I. Now we also know it starts at the origin, so at x equals 0 and y equals 0 when t equals 0. So that means pretty much r of 0 is the vector 0, 0 pretty much. So if you integrate this, you're going to get r of t is going to be v cos theta. Now attach a t because you're only integrating with respect to time, so don't integrate the cos term because theta is a constant in this respect and it's not a variable. You integrate the y component, so you're going to get plus negative gt squared on 2 plus v sine theta j. Now there's a t there as well, I forgot that. So let's just move this to the side very quickly and place a t there. Now you're wondering, I haven't actually placed any constants. Well, because I know this to be true. So my c's would just be zeros. So that is my straight up position equation. Okay. Now they want us to find dy dx. So there's pretty much two ways you can do it. You can use the chain rule, or you can create the Cartesian equation. Okay. Now we're probably going to create the Cartesian equation because you need to show this vertex is pretty much true. Okay. So converting this to Cartesian isn't too difficult. We're just going to convert it back into parametric equations and then substitute them into one another. So this one here is x of t is v cos theta t. Okay. This one here is y of t is negative gt squared on 2 plus v sine theta t. So if we substitute this equation into here, we can cancel out the t's, and this would be a function of x, so y depending on x. Okay. If you want to, you can use the chain rule here, because dy dx would be the same as pretty much dy on dt times by dt on dx, and you can see those changes in t's cancel out. So you could differentiate each of those with respect to t, flip this one and then multiply them, and you get dy dx in terms of t. At that vertex, we wouldn't know what that t is though. So substituting, let's use a different color now. We're going to make t the subject, so rearrange this one so you get t is x on v cos theta, and then we're going to pretty much plug this guy into the equation. So you'll place it here and place it here. So now you get y of x is negative g on 2 times by this all squared, so x on v cos theta all squared plus v sine theta multiplied by x v cos theta. Okay, now we can do some simplifying, distribute that squared, so you get y of x equals negative g x squared on 2v squared cos squared theta plus sine on cos is tan theta, and the v's cancel out, so all you get is tan theta x. Now this looks actually fairly complicated, but you need to remember that v and theta are constant, so it's literally just a parabola, because all of this in front of the x squared is a number, and this is just a number. So literally it's a number x squared plus a number x, pretty much. Right. What to do next? The vertex. So the vertex of our parabola, if we actually look at its shape, the particle is going to travel like this. The vertex is this top bit up here. Now at that point there, dy dx is 0. Okay. So now we've got this, we need to find out what dy dx is. So we're going to differentiate this with respect to x. So you get dy dx, do the power rule, bring that 2 down the front and subtract the power by 1. So you're going to get 2 minus gx on 2v squared cos squared theta. So I'm only differentiating with respect to x, I'm leaving the thetas. And if I differentiate this last time, I'm just going to get a plus tan theta, because that 1 would go to the front, and then you'd have x to the power of 0. Righto, so now you got this, set this equal to 0, so dy dx is 0 at the vertex of the parabola. Well, hopefully I spelled that correct, I don't care if I didn't. So you get 0 equals negative 2g, oh those 2's also cancel out, so it's just going to be negative g. Why isn't my rubber working? Oh, it's rubbing out up here. Righto. Let's just move this aside. Oh, what on earth has happened there? There we go. It selected some other stuff. Okay. So, with this equation here, let's just write that. Get rid of this. So, 0 equals negative gx on v squared cos squared theta plus tan theta. So now we're just going to solve for x. So move the tan theta to the other side, so you get minus tan theta equals negative gx on v squared cos squared theta. You can cancel out those negatives, so it will just be plus on both sides. Multiply both sides by v squared cos squared theta, so you get v squared cos squared theta tan theta equals gx, and then finally divide by g, and then you've got x as the subject. Now this actually doesn't match the question because they actually have used a trig identity. Okay, so in their question they want you to show the vertex, so let's just copy that, is this. So we need to show that this is exactly the same as this. So we need to look at pretty much this trig stuff in the middle here. So we know tan theta is sine theta on cos theta, and we also know cos squared theta is literally just cos theta times by cos theta. So if you have tan theta times by cos squared theta, what you actually have is sine theta on cos theta multiplied by cos theta twice. Not twice, I mean 2 of itself. And you can see one of those causes cancel out. So what I actually have is sine theta cos theta. Okay. Now, there's also a trig identity. If you have sine of 2 of an angle, that's equal to sine of that angle, sine of that angle, cos of that angle, times by 2. So what we can do is rearrange this so we have sine of that angle, cos of that angle, is equal to sine of twice that angle divided by 2. So replace those with theta. So sine theta cos theta is the same as sine of 2 theta on 2. And now if you plug this information for what we have here, what we're going to get is v squared, what is it, sine of 2 theta divided by 2, so put the 2 down here, g. And now that is exactly the same as their question. So all they did was a trig identity, okay? Now to work out the y value, you would literally just substitute this x value into this equation above, okay? So we've got to show the vertex, so we might as well do that. Did I destroy the equation? I think I did. Okay, righto. So I'm just going to move this out the way. Down there. Now I got to remember that equation very quickly. So what do we have for dy dx? We had this. Well, if I integrate that, I can actually work it out. But the c is 0. So if I move this back a step, what we're going to have for y is negative gx squared on 2v squared cos squared theta plus tan theta x. Okay. Yep, that's it. Cool. Alright. So now we substitute this guy, oh gosh, substitute this into here to get your y value, because you only have the x value of the vertex, okay? Tan theta, sine theta on 2g. So we're going to have y equals negative g 2v squared cos squared theta times by v squared sine 2 theta on 2g all squared plus tan theta times by v squared sine 2 theta on 2g. Okay, and from there we're going to start working this out. So to start off, pretty much we're going to reverse our trig identity. So we actually might write, instead of writing this, we might write its original form, so cos squared theta tan theta. So we can replace that. So we'll go sine 2 theta is 2, which is cos squared theta tan theta. Okay, so then we're just going to replace this guy in here to make the trig actually a bit easier. Okay, so let's move that, and then we can fix it up a bit later. So we'll get y equals negative g on 2v squared cos squared theta times by v squared cos squared theta tan theta on just g, because there's no 2 now, plus tan theta times by v squared cos squared theta tan, running out of room, tan theta all over just g. Okay, so if we do that, we can see that will cancel with that, and that will cancel with that, and there's a squared behind all this as well, so don't forget that as well. So we're going to get y equals negative g. Oh, we also can cancel out those g's, but it will still be a negative, so we get negative 1 on 2 multiplied by just tan squared theta. Okay, this one here, only thing that cancels, well actually nothing cancels here, so you're just left with plus v squared cos squared theta, and this will be now a tan squared theta all on g. Okay, now tan theta is sine theta on cos theta. So squared that, it's the same as squaring both of those. So if we have tan squared theta times by cos squared theta, we can see all we're going to have left is pretty much a sine squared theta. So this here is just the same as sine squared theta. So we're just going to do that very quickly. So you get y equals negative tan squared theta on 2 plus v squared sine squared theta on g. Okay. Now we want to combine those two together. So we're going to multiply both sides by g here. So y equals negative g tan squared theta on 2g, and multiply this by 2, so you get plus 2v squared sine squared 2 on 2g. Okay. What we do from here now is we look at our y and what we're actually trying to get. So let's just bring that down. Actually, you haven't done this second part yet. And see what we need to manipulate. Okay. There will be a way to combine some things here. So we will need a trig identity, perhaps, because we need to show that this is the same as that. Okay. What do they have in common? V squared tan squared theta. Hopefully we haven't made a mistake anywhere. I don't think we have. Negative. Okay. This will cancel. Sure, that didn't cancel out at all. That cancels, yep. Tan squared theta. Just going to look at the trig identity very quickly so you can see this is actually quite raw. Tan squared theta. Sec squared. Not sure with this last bit actually. Anyway, I might leave that one for now and just continue. Well, actually, I might leave the end of this video here and I'll do a part 2. Right, I'm going to end the video here just so I can figure out this last bit and see if I've made a mistake. I'll see you in the next part, hopefully.